Hey there, welcome back to another video with the Math Doc. If you're new to this channel, please subscribe. We're going to continue with our journey into solving linear equations, and we're working on multi-step linear equations. This is a follow-up to a few previous videos where we've discussed the properties of equalities here, and we've discussed using inverse operations, addition and subtraction, or multiplication and division in order to simplify our equations and in order to isolate our variable. So we have equations with variables and we want to solve for the variable. It's usually x. And in order to do that, we basically have to isolate our variable. And so we simplify the equation, try to get our variable on one side of the equation and everything else on the other so that we can solve and find out what x equals to. So in order to do that, we use the various properties of equalities, and again, I will have links to the videos that discuss these in detail down in the description. But we have the addition property, we have the subtraction property, the multiplication property, and the division property. All of these help us simplify equations where we choose to use operations that are inverse to those in the equation. And this is all talk, but we will use this video basically to look at several examples, starting off with simple ones and working up to slightly more difficult ones. But we will basically just look at examples in this video just to review the material in the videos that are linked below. So let's get started with our first example. This example will be 3 times x minus 7 equals 10. So what do we have here? We have the variable x. It has a coefficient, right? 3 is our coefficient. A coefficient is another word for something that is multiplying our variable. We have a constant here, and we have a constant here. And again, the constants are the numbers that don't change. So we have variable, and these are usually signified by x, right? We use the symbol x, and then we have constants. And they do not change. They are numbers. Let's look at this equation and see how we simplify it. So first of all, we see that we have constants on both sides of the equality here, and that complicates things. So our first step should be to try and get our constants to one side of the equation, and we can do this by using the inverse operation to the minus here. So what would the inverse operation be to the subtraction? It would be addition. So let's add 7 to both sides of this equation. Remember, the addition property of equations means that we can add the same number to both sides of the equation, and the equation will continue to hold true. So what do we have here? On the left, we have 3 times x, right? That comes down. And then we have minus 7 plus 7. And that equals, on the right, 10 plus 7. Okay, so let's take another step down and simplify. We have 3 times x minus 7 plus 7. Both cancel each other, right? So we have 3 times x plus 0 equals 17, where I've done the addition here on the right. The 0, of course, is not necessary to hold on to, so we have 3 times x equals 17. What will be our next step? Let's write this out without the 0. Our next step will be to try to get rid of this coefficient, right, of this number that is multiplying our x, so that we can isolate x completely. What is that inverse operation to multiplying by 3? The inverse operation to multiplying by 3 is division by 3. So let's go ahead and divide by 3. And instead of writing division, I'm going to write this as a fraction. Okay? Because remember, when we divide a number by 3, it's like we are multiplying by the fraction with the denominator of that number. So now what we have here is 3/3 times x equals 17/3. And we can simplify this further, right? So 3/3 is exactly 1. So we have 1 times x equals 17/3. What is 17/3? Well, this is we can do the division separately here. Okay, 17 divided by 3. 3 goes into 1 0 times, but it goes into 17 5 times. 5 times 3 is 15, so we have a remainder of 2. So 17 divided by 3 is just 5 2/3. Okay? Now, we don't have to write that 1 anymore, and we have x equals 5 2/3. So that is the result of this original equation, 3x minus 7 equals 10. And you should really check the result by inserting it right inside the original equation. And I will do this one with you so that you can see how it's done. So we have 3 times x minus 7 equals 10, right? This was our equation. Now let's substitute x equals 5 2/3 in this equation. So we have 3 times 5 2/3 minus 7 equals 10. Let's do this slowly. Let's turn 5 2/3 back into an improper fraction, right? It was 17/3. So just that's what we got up here. So we have 3 times 17/3 minus 7 equals 10. That's our equation. What is 3 times 17/3? Again, our 3's cancel here, right? And we have 17 minus 7 equals 10. And 17 minus 7 is 10. And so we have checked our result, and it is correct. And so that is how we do the checking. We substitute the result for x in the original equation right here. Let's look at another example that'll be a little bit more complex this time. Okay, let's write out this example here. 5 times, and we're going to open a parentheses, x plus 2 equals 20. Okay, so why is this problem a little bit more complicated? Well, obviously because of the parentheses. So there are various things we can do, and we're going to solve this problem in 2 ways. So I will start with just simplifying the equation, right? That should be our first step. And when we have parentheses, one thing we can do is we can use the distributive property. As a reminder, distributive property shows us how to open parentheses. So let's do that on the left here. The distributive property says that 5 times x plus 2 in parentheses is just 5 times x plus 5 times 2, and that should equal 20 on the right. Okay, now because there's a single number in each one of these parentheses, we can drop them. And so we get 5 times x plus 5 times 2, which is just 10, equals 20. We can simplify further now using the addition property of equalities, right? Let's use the addition property by, actually it's not the addition, it's the subtraction. The subtraction property, because we're looking at the inverse property 2 plus 10. What is the inverse to plus 10? It'll be minus 10. So let's subtract 10 from both sides of this equality. Okay, so we get 5 times x plus 10 minus 10. We'll write it fully out, equals 20 minus 10. Okay, we're almost there. One more step. 10 minus 10 cancel, and 20 minus 10 equals 10, right? So our last step will be to try to isolate x completely by doing something with the 5 that multiplies it. What is the inverse property of multiplication? Well, it's division. So we will use the division property now. Let's write that out as divide by 5. And here again, I've used the fraction as a symbol for division. So we have 5 times x divided by 5 equals 10/5. And now 5 in the numerator and 5 in the denominator cancel, and we left with x equals 2. And that is our result, 2, because 10 divided by 5 is just 2. Now we will check this. How do we check it? Again, we substitute our result inside our original equation. So we had 5 times x plus 2 equals 20. So let's substitute here. 5 times 2 plus 2, right, equals 20. What is 2 plus 2? That's exactly 4. So we have 5 times 4 equals 20. And indeed, 5 times 4 is 20, so 20 equals 20. Great. So x plus 2 is the result. Now let's look at this problem again. So this was our equation. And this time we'll solve it not by using the subtraction property first, but by using the division property first. So let's write it out again. We have 5 times x plus 2 equals 20. Okay, now instead of simplifying, let's start by using the inverse property to 5 times. What is the inverse property to 5 times? It's divide by 5. Now here things get slightly tricky because we have to remember here to be clear about the order of operations. Okay? Now, when we have parentheses, the order of operation is that multiplication times what's in the parentheses comes later to what's inside. So we do not have to open the parentheses, but we have to make sure that when we divide by 5, we are dividing the whole parentheses by 5. So how does that work? Let's write it out. Like we like to write divide by 5 right here as a fraction, and we have 5 times x plus 2 divide by 5 equals 20 divide by 5. I'm going to go real slow on this because I find that these steps are often very confusing when we first start working with equations. I'm going to write out the left-hand side a little bit more fully. So 5 times x plus 2, and instead of writing divide by 5, I'm going to write it as multiply by a fifth. That equals 20/5. Now I'm going to use the commutative law. Do you remember what that is? The commutative law, or the commutative property, says that I can change the order of operations if they are of the same importance. So what I'm going to do is I'm going to write this as 5 times a fifth. So I will put the fifth here before the multiplication by the parentheses. So I've switched the order here. I'm able to do that because in both cases it is multiplication, and that equals 20/5. Now it's way easier to see what's going on. So we have 5 times a fifth. Those two cancel because 5 times a fifth is just a whole. It's 1, right? So we can move those out of the way, and we remain with x plus 2 equals, and finally we can say that 20 divided by 5 is just 4. So essentially what I did is I isolated not x, but I isolated what was in the parentheses. So sometimes we can start by isolating the number or the variable or the item. I'm going to write item because it could be anything inside the parentheses. And we will see a few more examples where this becomes clear. So now that we have x plus 2 equals 4, we know what our next step is. We want to use the inverse operation to plus 2, so we'll do minus 2, right? We'll subtract 2 from both sides, and we have x plus 2 minus 2 equals 4 minus 2, and we know by now that we can write it out as x equals 2, and we saw that that was the result we also got previously up here, right? We got x equals 2. So we got the same result in both cases. So the important thing here is to understand we can go in both directions, and they're both correct. We can try to first isolate what is inside the parentheses. So treat that as a variable and just isolate it, and then go ahead and simplify more. Or we can start by simplifying the entire equation by usually using the distributive property and then moving forward with that. So this is the end of this video. I made it a short video so that you could see a couple of simple examples and you can review them again. And in the next video, I will just continue with a few more examples of multi-step solutions for linear equations. And these will be progressively more complicated, but we will go step by step. So thank you again for joining me. If you're new to the channel, please subscribe. If you have comments, please include them. Any questions, I'm happy to look at and perhaps dedicate a tailored video to specific problems. Of course, like, and I hope to see you in the next one.